the machine learning session for DevDojo. Here's the content that we'll go over in the lecture. We'll go over key concepts in machine learning. After a quick overview of that, we will jump into how we can use machine learning as a company, what kind of things to be careful of when doing so. You'll be able to hear some more details about actual use cases in the advanced session that I just mentioned before. First off, key ideas in machine learning. I know you may hear AI quite a lot these days, but I wanted to first look at how AI and machine learning are related. Again, so we hear AI quite a lot these days. That stands for artificial intelligence. That essentially refers to technology, so software or computer programs that can essentially mimic or reproduce humans' intellectual activities. To give an example, let's say you want to recommend an item on Mercari, and you can say, all right, this term, this word might make it easy to sell the item. You can make a pretty simple algorithm through AI to do so. And machine learning, which is what we'll be looking at today, is essentially one method in order to implement AI, one way to implement AI. We often refer to machine learning that doesn't use AI as rule-based methods or statistical methods. For example, it can be really any sort of simple thing, but let's see. Say you want to use a machine learning model to recommend items based on the user's context. That can be done through more rule-based methods. Another word I think we hear a lot these days is deep learning. Deep learning is a method to implement machine learning. Within the field of machine learning, there's something referred to as deep neural networks. So machine learning that uses that kind of method is what we refer to when we say deep learning. Deep learning has become quite strong these days. Some do just refer to it as AI. That's my general sense. You can utilize neural networks to achieve some sort of thing. In these circumstances, we would refer to it as deep learning. So that's an overview of the different terms. Now let's go a bit more into actual machine learning. I can't say all, but maybe more than 90% of machine learning models are done as you see here in the slide. Let me just break this down a bit by bit. We have X in this equation, so X and Y is the data set. X refers to, so the input, the features, and Y refers to the labels, the target, and what you're trying to predict for. And combining X and Y is what we refer to as the data set. You see the function f applied to it below. This refers to the essentially function with that parameter. This is what we refer to as the machine in machine learning. And what we can do is define the loss between X and Y. When we say loss, it does depend on the task in machine learning, but it can be used in all different sort of situations. Let's say, for example, mean squared error or cross entropy. When you want to measure these kinds of indexes, that's when we can use this function. And last we have G. This essentially refers to the regularization terms that are needed to get everything running stably. Let's say, for example, if we want to use Mercari data to predict the price of an item. In these circumstances, what you would do is apply this function. So here again, X is the item name, category, or brand, any other sort of item-related data. And what we want to do is predict the price. So we would set that as Y. You can have a really big range of simplicity to complexity, but you can also have linear regression model, just for example. I'll go into this a bit more later. And the loss function refers to just trying to get as close as possible to an accurate result. And we just apply these parameters in this function to continue to train the model. So again, this is probably how more than 90% of machine learning models are trained. There will be some differences in these parameters and how the equation is set up, but what you're doing is essentially the same. Here are some different patterns for how you can put together X and Y. One very common way is, let's say, supervised learning. In these situations, you have a accurate set of data, and you want to train the model to get as close as possible to that accurate answer. I included some links to actual examples at Mercari. You can just click them and check them out yourself later. For example, let's say you want to predict the item price by looking at other information. And let's say you want to detect inappropriate messages in transactions and enable them to be reported by CS members. And another one is called unsupervised learning. In this situation, you don't have a set of answers already of accurate data, but you want to still train the model somehow. Let's say in Mercari, that can include things like item embedding using word-to vectors. There's no single answer for item embedding, but rather you want to be able to define it yourself and train the model. And another thing I think we've heard about recently is ChatGPT. You can kind of combine them, do some supervised learning, and also reinforcement learning, as I'll go into a bit later. And one other one you see here, reinforcement learning. There's no single set answer here, but what you want to do is enable some sort of a reward to come back from the environment after a certain action is taken by the model. At Mercari, one way we use this type of learning is on the home screen. Let's say there are a couple of options for which components to display on this screen, but you won't know how the user will react until you actually display it on the screen, on a home screen. So what you can do is optimize the components displayed on the screen through reinforcement learning. Okay, so moving on here, let's look a bit more at supervised learning. There are two main types of supervised learning: regression and classification. Regression refers to where you have a target variable, and as I was saying before, you have a continuous value on y that you're trying to get to. Let's say, for example, the item price, that'll be from 1 to whatever the max value could be. You're trying to get that continuous value and get it as close as possible to that actual value. So you do regression, and you can get the average or the median, and essentially keep using that distance throughout the process. And classification refers to where it's not a continuous value, but let's say 0 or 1, a categorical value as we refer to it. That'll be 0 or 1, or a day of the week, this day or this day. Basically, category value as we refer to it. Something that's not a continuous value. To give it a task to look at which label is actually attached. Interpreter switch.
I've added some links to examples, so if you're interested, please take a look. Next, I'd like to talk about how machines actually learn. As I mentioned earlier, machine learning happens through actually minimizing loss. And if that loss, for example, is on the regression side, that might be mean squared error. So you get the machine to calculate this error. And if you're adding a label, then or classification, then you might be using cross entropy. So that allows you to measure. You define a criteria and then make sure that you're minimizing the loss of that specific criteria or prediction. This is not for everything, but recently, within machine learning, you often use gradient descent. So for example, the F from the formula before, you try to get a differentiation and see if there's loss or things go down. And so you move the point of loss in order to, and move that around in order for the machine to learn. If you look at the left, the photo or the image on the left, it's a bit of a strange shape. But before you get to the bottom, if you get stuck in a different valley, so to speak, then you might not be able to completely learn everything because it gets stuck there. So you need the correct model for the type of work that you're trying to do. And so the most difficult thing is to choose the appropriate model. Now I'd like to some specific examples. The most simple model is y equals wx plus b. So y is the data set, is part of the data set. So this is something quite simple you learn in middle school in Japan. So there's two parameters, w and b. Let's say we're predicting the penguin's height. So let's say the weight is y, height is x. And how does this machine learn? So with y equals wx plus b, we differentiate. So first, we use the mean squared error and use the difference between the two to find out the loss. And then the difference here is what the loss is, the calculation of the loss. And so first, we use the parameters. And if we divide it like this, we differentiate, we can get this formula. And after we decide on an inside value for w and b, after differentiation, so we're doing this process with the formula, getting data into x and y as much as possible for each batch. And if you look at on the right-hand side, you can see there's a red line. And with this, you get a very simple machine learning model. So here, y equals wx plus b. It's a quite simple regression. But of course, realistically, we use a much more complex model. So rather than people differentiating it manually, for machine learning, generally speaking, those models automatically do this for you. So I would say that is currently where the industry is at. That was a simple example. So for these are things with a very linear correlation, but within machine learning, that's not necessarily the case. There are often issues or problems that we're trying to solve that don't have a linear relationship. In those cases, we use kernel functions. So that allows you to transform features into spaces where there are classes. But what you do is essentially the same. So even if it's like an n formula, then you want to differentiate, get to the smallest value. So the basic concept is the same. These are just examples of linear and non-linear models. So there's a very famous Python library where you can look at some of these models. At Mercari, there's something called scikit-learn. The person is somebody who made this very famous Python library. They actually work at Mercari, so I think it might be interested if you'd like to hear their thoughts or speak with them. When you are training your machine, I'd like to talk about some things that to take into consideration. But first, I'd like to talk about trade-offs. So there's this concept called underfitting versus overfitting. Underfitting is when the machine isn't able to learn everything completely, and overfitting is the opposite, when the machine has learned too much. So what does it mean by too much? You might be wondering what that situation looks like. If you look at the charts on the right, Let's say you want to divide the red dots and the blue dots. You can see there's the green line that's going between them. And you can see how very specifically it weaves back and forth. So this is what it looks like to be this is what overfitting looks like. If this was for all data, then it wouldn't be an issue. But of course, there is information outside of the data that the machine learning is using. And there's some data sets that are slightly different from the data within machine learning. And so for machine learning, the most important thing is its ability to generalize and its ability to adapt and learn from within new sets of data. So if you look at the green line, even with a slight deviation, ability to predict between the red and blue will change drastically. And so this is what we call overfitting. In this sense, it's a trade-off. We need to know how well everything is fitting with the trading data, but we also need to maintain the robustness of new data. So there's a trade-off between these two things. So there needs to be some solutions to or ways to control this trade-off. So how do we do that? The most recent machine learning models, sometimes we divide the data set between the training model, the actual set. So when we're training the model, how much new robust data can we get? Sometimes you incorporate some unknown data on purpose in order to make sure that your data, your machine learning model continues to predict at a high accuracy rate. And so you're training the model to work with unpredictable data too. In addition, if you have multiple data models, then we know that it allows for the system to be more robust. And so you can actually combine multiple machine learning models and work together in order to solve a single problem. There are, of course, other trade-offs. And the question is, where's the compromise? For speed and accuracy, larger models are more robust, but they can also be slower. So depending on the project, you might need to choose the trade-off. The same can be said for cost. Of course, there are a variety of costs that we can talk about, but the machine itself costs money. It costs money to train the model. In addition, it costs a lot in terms of manpower in order to maintain the model. So those will be defined according to the parameters of the project. We don't have very much time, so I'm going to keep going. Next, I'd like to talk about pre-processing. This is essentially about how we feed data into the machine learning model, but we need to process it before we feed it into the model. So the model itself is in a computer. It's a computer. So it can easily understand mathematical equations, information, vectors, scalars, matrices. But what about categorical data like text, audio, or images? Data that is optimized for human consumption. That's more difficult for the models to understand. And that is why we need to pre-process data. These are some examples. For example, one hot encoding is creating a vector from categorical data. I think this is a easy to understand example, but let's say there's a day of a week. Let's say Monday. For Monday, the section that's Monday, we would add 1. If it's a Wednesday, we also have 1, change it into a code. Next is a text. If we are using what and hot encoding for text, can do the same thing. I think this is a pretty easy example. So let's say there's 3 words: dog, cat, bird. If all of those words exist, then you add 1. It's counted. So that is the pre-processed state. So you can see how it's being pre-processed, but this information that's easily used, accessible for people, that needs to be converted for the machines to be able to read easily. These are examples of machine learn machine learning models. First example is language models. I think many of you use ChatGPT, but it is a model which allows you to process language or words. Language models essentially use probability distribution to understand word sequences. For example, let's say they see the words they and look, they will calculate the probability of what word would come after that. Not going to go into too much detail, but ChatGPT is a good example. And specifically GPT-3 has about 175 billion parameters. The model that I was talking about, that where we calculate the height and the weight of the penguin, that model only has 2 parameters, so you can understand how big or complex the parameters or the model itself is here. Next, let's talk about machine learning for images. The most modern method for this currently is deep learning. What sort of pre-processing do we do beforehand? For images, images have a height, width, and then 3 color channels. So it can be processed as a 3-dimensional tensor. And what's used quite often right now is something called the convolutional neural network, or CNN. This essentially imitates a human visual cortex, and each cell is folded into a quite complex pixel. For the legacy method, we use handcrafted feature extraction, and for that, things like PCA is used. And at Mercari as well, we use the legacy method too. For AIs that identify if there's a road, you can see on the bottom right, it uses this method. I think also Google Meets, you can see our backgrounds fit seamlessly with us. Um, but for that, oftentimes CNN is used. Let's keep going. Interpreter switch.
And in terms of using machine learning, let's look at the kinds of things to keep in mind. The first thing to be aware of is what is a good use for machine learning and what is a not so good use for machine learning. So starting off with what machine learning is good at, the first thing would definitely be, well, let's say there's been quite a big amount of data, and now you want to automate the process. This has to do with how to set up the application. You can't really do machine learning without a big set of data. So you first have to have someone create that set of data. For us, as a company with customers using this service, that already serves as a source of data that we can use. But instead of us just taking that data and attaching labels, something we can actually ask or have customers do for us. You have to make the data in a way that will enable that process. Through this process, instead of just manually attaching labels to everything, we can do it through a way that we refer to as collective intelligence approach. It's important to ensure you are properly utilizing collective intelligence to really effectively use machine learning. For us, we have quite a significant source of data which enables this process. And let's say, as we were talking about before, there's also rule-based or statistical-based ways to do things instead of using machine learning. The idea is that the advantage here to use machine learning is that it no longer has to be processed manually by human beings. The example we gave before was pretty simple, but in more real examples, there's quite a significant source of data to go through. And you have to look through manually to decide what value means what, which requires proper understanding of all the different data. However, you can use machine learning instead to just have the model do all this for you, meaning we managing the data don't have to understand all the characteristics, but rather we can just leave this up to the model. One disadvantage of machine learning is that the cost can be quite high, really, no matter what you're trying to do with machine learning. So implementing it requires quite a lot of advanced consideration for the actual ROI of the process. And as you see here last, the more data, the better. As I said before, you need to have the data to go about it, but it's not about just having data for the sake of having data. What we need to think about, for example, is let's say the data is really disorganized, then it makes it pretty hard to do machine learning. And sometimes you need to split the data. We were talking before about having to split the data sometimes to avoid overfit. That means the data has to be organized in a way that makes it possible to split it. Another common issue is where the data changes throughout the year based on the season, for example. This is called concept drift in the machine learning world, refers to seasonal changes, or for Mercari, say changes in the laws where the actual labels that we are using themselves change. You need to be able to handle these changes in the way the data is set up to be effective. Let's look a bit more at why machine learning can be so expensive, such high cost. If you try to do a machine learning process, these are all the different elements that you need to consider. In the middle, you can see a really small black box. This refers to the machine learning code that is used to actually train the model. Before getting to that stage, you need to first set up the whole project, configure the project. You then need to go to BigQuery, to SQL, and create a pipeline for the data. And you also have to do pre-processing, as I was talking about before. So feature exact extraction, as is written here on this slide. You have to ensure that pipeline is properly set up and verify the data and also manage all the resources for machine learning. And what else? Also, if you're going to do A/B testing, then you will have to use tools to do analysis of the A/B test. After creating the model, then you need to also have monitoring in place to make sure it's still achieving the original purpose. So that's just a kind of long way to say there's many different things you need to do for machine learning projects, and that's why the cost can be quite high. Thus, most machine learning engineers, before actually starting to use machine learning, will look into if there are any other options to avoid actually using machine learning if it's possible to do so. I'll just skip over this part, and now let's take a look at data at Mercari. First off, we have a really vast amount of data at Mercari. So this slide is a bit outdated, but you can see here it says 3 billion items with image and text data. Labels of these kinds are attached to all the different items. And the kind of information that we can get is not just information about the item, but also all of the different actions taken by users on the app. Purchasing an item, searching, using a certain term. This is just an example of the many forms of data we have through the app. And now let's look at the kind of projects we do utilizing this data. We do quite a lot of testing. So the examples I'm going to share might not match the actual current app. So please just be aware of that. Let's take a look at just one part of the many different projects utilizing AI at Mercari. So layout personalization refers to the home screen. Let's take a look at the form, the flow for home screen recommendation. One thing that's pretty unique about Mercari is that once one item is purchased, then it cannot be purchased by another user. I think those who are have a lot of knowledge in this area might know what I'm referring to. That makes it quite challenging to set the problem, create the topic for a machine learning model. So instead of managing the item data, what we do is manage the topic or the category. So instead of saying golf club, instead of managing it as a golf club, we manage it as a topic of golf that includes the different items within it. Then we can rank topics to match the interest of the user and display them in the order of highest interest. For example, here you can see the way the customer actually browsed on the home screen. So we're not displaying it just based on what they actually looked at, but we look at what topic the item falls under. We have to be aware of that, and then based on that information, recommend the items in a very intentional order. I touched on this a bit before, but it's not just the components themselves, but the actual positioning of the components is another thing that we optimize. Multi-armed bandit, as we refer to it, is actually an example of reinforcement learning. Lots of trial and error will eventually bring us to an order of components that really most interests the customer. So not just the components themselves, but also the way they are displayed on the screen. Next, let's look a bit at the search page. The result of the search, the way we actually display that, all the ordering is done using machine learning. So SERP refers to the search page, search engine result page. There's a really incredible amount of searches being conducted on the app at the same time. What we can then do is utilize machine learning to re-rank everything to manage that significant amount of searches. There's a link to a blog here with some more detail if you're interested. And next, let's look a bit at an example from marketing. So coupons. We can use machine learning for distributing coupons. For example, coupons aren't really the easiest sort of thing to use machine learning for. Or it's not that we want people to use them because they're getting a discount to buy the item. What we want to do then is optimize it in order to reduce the cost as much as possible of distributing coupons. Interpreter switch.
We have a question here. When recommending items in a topic, let's say in the fashion genre, such as clothing, I think people consider a lot of products in the same genre, but I wonder if recommendation within the same category or genre would not work for things like keyboards or chairs. You only need one item for that, and so I'm wondering if it wouldn't work. Recommendations within the same genre wouldn't work. So is there any difference in the function for each category? Right. So there's a different logic for each category that happens. But for some things, I think I'm assuming that for some items, once you buy it, you don't need multiple. We have a few components for that. And for example, let's say you viewed some items and your items are recommended to you according to that. Even if you buy an item once, I do think that our system currently will recommend similar items to you. There's also a component called recommending, where it recommends items that you've already bought or something similar. So if you buy a chair, then it might recommend a table to you next. And so I think that those components are allow you to cover multiple categories. I hope that answers your question. Thank you very much. Let's move on. So in regards to listing, this is something called AI listing. Within the application, there are a few small modeling models. For example, if you open up the photo mode, it'll automatically take you to the barcode mode. And if you scan the barcode, then it'll give you information about the item, the category, the title that allows you to quickly list items. Received another question? What's the best language for machine learning? I'm assuming you mean programming language. For that, I would say Python is used the most. Okay, continuing on. So this is an example of barcode listing. So if you scan its barcode, you can see that the description is filled out automatically. And this one is AI listing. So for items that don't have a barcode or no particular item catalog, if you take a photo of it, there's a function that allows you to fill that automatically fills out your item, title, description. So this model takes information from other items that look similar to the image that you've uploaded, and will recommend or give you automatic ideas for the description and information regarding the item. Let's keep going. This is an example used specifically within trust and safety. This is a project that monitors transaction messages. But within transaction messages, there are some transactions that happen that should not be happening. Let's use Twitter instead. These are examples of people trying to work directly with the lister. And so this is actually against our usage policy. And so the model picks up this information to make sure that we can monitor it. We used to use a query and look through everything manually, but that cost us a lot. I can't give you the specific numbers, but after we switched over to our AI model, we can see that our accuracy went up a lot, and we're able to check for these uh, types of transaction messages, suspicious transaction messages. In addition, we have some tools to help us with our contact center operations. So when a user sends in an inquiry, there's this up to this point, there was a CS agent. They look for a template, a response template. There are a few different ones. They had to look for it manually on their own and then respond to the inquiry. But currently, we use machine learning to suggest these templates to the CS agent. The goal of this project is to reduce the average handling time for CS agents. So that way, agents are able to reduce the time that they need in order to respond, and this is improving the user experience.